I want to present Java visualization of algorithms defined in this document. Visualizer has 4 parts. Sensory input, we enter a pattern here to build sequence. Region columns, region cell on the right by layer. I call them region slices. At the bottom we have spatial and temporal cell and column information. By clicking on the column, we will see column proximal synapses connected to input space. Orange spot here is column center in sensory input space. A gradient color represents synapse connection permanence. Green is connected and red is disconnected. At the bottom we have spatial column attributes. Scalar attributes on the left. In the center we have a list of proximal synapses, and on the right neighboring column. In this table we can sort any attributes by clicking on the header. And by the way, if you sort by attribute, the sorting applies when you switch column, which is very convenient because when you run algorithm and want to see how set of particular attributes changes over time. So we switch and we see sorting still applies here. You can select particular proximal synapses by clicking on it in the table, and it also will be highlighted in sensory input area. So let's sort proximal synapses by distance, how far away we located from column center, and select the first one. And this one is overlapped with column center. We can use the keyboard up and down keys to go through. So let's go down, and as we go down in this table, we're moving far away from the center. Same rules applies for neighboring column. We can sort by any attributes, and let's also sort by distance. And if you click on a neighboring column, it will become highlighted in a region, and you can see it. I forgot to mention neighboring column here in the region is grayed out, so we can see them. And number of them depends on location. We have more in the center and less by the border and in the corner. Also, number depends on input radius. For this input radius, we have 20 columns. Let's change it. So it's a 5. Let's make it 9 something. So now you see the gray area is much bigger. We have more columns, 88 here. So let's click on column cell, and the cell is the selected cell has a red circle around it, and other cell in the same column we have yellow orange circle around. So this way you can see the cells from the same color. By clicking on a cell, we bring into view temporal cell information here, and cell attributes here, and also we see cell state buffer. We can change how far back in time we want to remember the cell states. Now we have 6 steps to remember. Let's change it. We go to edit parameters, click on temporal tab, and change from 6 to 7. And as you see, we have 7 steps now. In the center here we have segment and segment updates and related synapse information. and at the right we have active columns. There is no any information here at the moment because we're not running any sequence, and there is no temporal state for this region. So now let's load and run some sequence to see how region state progress. So this is pretty simple sequence. It represents square bouncing back and forward in a predictable way. Let me reset HTM state. So as we step through sequence, spatial pooler produce sparse distributed representation from our inputs. Sparse distributed representation here is set of active column in our region. Let's click on a column. The column has overlap. So this one has overlap. It says 3, which means the column has 3 proximal synapses connected to input overlapped by this black square, and as you can see, indeed we have 3 green squares here and 1 red which is disconnected. So the green is not very obvious because the connection is still weak. It will increase as learning progress. So if we go through and click now, you see, so the permanence has increased and we have defined green color now. So let's sort by active state neighboring column, or we can sort by overlap. Pretty same result for this reason. So as you see, all active columns have very good overlap with input pattern. So now let's remove the selection and examine the temporal pooler state. We see active cells here, and some of the active cells has a red dot. It means cell is active and also in learning state. So let's click on it to see results. So in cell properties in our cell state buffer, at current step we have active and learning, which is same what we have in the region slice. So and now we can see the formation of segments has begun. Cell has 1 sequence segment so far. Let's click on it and check distal segments detail information below. Also in a region you can see cells surrounded by black square. We are connected to our selected segments through distal synapses. So, and yes, if we select distal segments, it's got highlighted, and all that cells surrounded by a square will be highlighted. So as we go through, so we all got highlighted. So my good guess, connected cells were active in previous step. Let's see. So we just click on it, and yes, indeed it was active in the previous step. So now let's turn off the spatial learning. We needed to have spatial stability, and let's run temporal pooler for some time. Okay, so now you see we have dark blue cells. So it means now cells, we have some cells in predicted state. So and let's see why they are predicted. Let's click on it. And this cell is predicted because of this segment. This segment is active and also learning. What it means, it's connected to enough number of active and learning cells. So let's click on it, and as you see, yes, we have a number of active cell and also in learning states surrounded by that square. Let's just go through them. Select synapse in the table and highlight it. Let's see if prediction was right and cell will become active in next step. So we click on the next on the step, and yes, it becomes active. So and my guess, if we click on any active and learning cell around the same picture, the cell was predicted in previous step and active now. So same here, same, and same. So now this is activation, one-step activation. So now let's run temporal pull for some more time. Okay, so now we see many light blue cells representing they represent farther back in time prediction. Let's select one of them. So and why this cell is predicted? It's predicted because of this segment. Segment is active. So if we click on it, we see active cells, and the cell will be predicted in 3 steps because of the segments, because of the set of the cells. And with each step, segment activation will be moving up in segment table. So let's see. We step, and now cell will be predicted in 2 steps, and that active segment is moving up. So let's click on it, and here we have active cells which predict activation of selected cell in 2 steps. So let's highlight them. Click on step again, and finally we're predicting cell activation in next step. So it's dark blue. It means we predict the cell will be active and learning in next step. So one thing to notice, we'll see all bunch of segment updates accumulated. So take a notice of the permanence value for all segments now. So when we click step, this cell will become active and in a learning state, and all segment updates will be applied and permanence will increase. So let's see. Yes, it's applied, and as we see, the permanence has been increased. So far we saw the end result of temporal puller work, but in my next video we will look deep into temporal puller and examine segments formation from segments updates in very great details. If you wanted to download the source and play with it, it's available on GitHub here. Thank you very much for watching.